Okay, welcome back to the last video of second order differential equation for MA 1203 Business Mathematics 2. Okay, so now here we have a variable term, yeah, instead of a constant term, yeah. So this is not autonomous anymore, yeah, because on the right hand side we have a function of t, yeah. So explicitly the equation will depend on t, yeah, the variable t. All right, so now bt is a function. Okay, so we will learn the solution only for the two following functions. So very similar with the difference equation, yeah. The first one is the polynomial, yeah. If here we have polynomial, then we assume that the solution, the particular solution, will be the same order polynomial, yeah. So this is of order n, yeah. We have here also of order n, but different coefficients, yeah. So these are the coefficients that we want to find. And the second one, if we have exponential, yeah, times polynomial, yeah, or it can be just exponential, yeah, then the solution that we assume will be the same exponential, yeah, but of course with different coefficients, yeah, and the coefficients we want to find. All right, let's see an example. Yeah, the first one is on the right hand side we have a polynomial, yeah. This is polynomial of degree 2, yeah. And of course for this one we have to find the homogeneous solution first, yeah. Homogeneous equation, yeah, the right hand side is 0, yeah. And then we have the characteristic equation r squared plus 3r minus 4. If we factorize, it will be r plus 4 times r minus 1, and we have the roots is minus 4 and 1. Okay, the homogeneous solution will be this one, right? Yep. Okay, so now of course we just find the particular solution. Yeah, we want to find the particular solution because on the right hand side here we have a polynomial of degree 2, yeah. Of course what we're supposed to do here is we assume that the solution will be also polynomial of degree 2, yeah. So t squared plus t and plus constant, but with different coefficients, the coefficients which we are going to find, yeah. So a2, a1 and a0, yeah. And of course we have to check, yeah, whether there are terms, yeah, in the particular solution and in the homogeneous solution which are the same, yeah. So here the term is e to the power of minus 4t, e to the power of t, and we see that there is no such terms in the particular solutions. Okay, so we will be okay. And of course, to substitute back to the original equation, we have to find out what is the y accent and the y double accent. We already assume that the y is this one. What about the y accent? The y accent will be the derivative of this, of course, will be 2a2 times t, right? What about the derivative of this? It will be just a1, right? Okay, so now we have to find again the second derivative, yeah. So what is the yp double accent? Yp double accent will be, of course, derivative of this will be 2a2, derivative of this will be 0, right? Okay, put it back to the original equation. We have, what is this? Yp double accent, put it back here, 2a2. And we have yp accent, this one, 2a2t plus a1. We put it back to this one, 3 times the y accent, yeah, we put it back here. And then the last one is the y. We put it back to minus 4, we put it the yp in here, yeah. So all of this we put it here and we get this, right? And this is supposed to be equal to what? To t squared. Okay, so left hand side and right hand side should be the same, yeah. So we can try to find out, yeah, the solution, yeah. We can collect all the coefficient for t squared here. You see, where is the t squared? Only this one, yeah, minus 4a2 t squared. And then we collect all the coefficient for t. Where is t here? No t. Okay, here t, 6a2. Yeah. Where is another t? Okay, this one minus 4a1, right? So this is coefficient for t, and then the last one will be the coefficient for constant. This is a constant, 2a2. This one is t. Okay, this one, 3a1, is a constant. And from here we have minus 4a0, which is a constant. Okay? So again, left hand side, right hand side should be the same. So this is the coefficient for t square. The coefficient for t square is minus 4a2, and the coefficient for t square here on the right hand side will be 1. So we have minus 4a2 is equal to 1. What about this one? This is a coefficient for t. Do we have t here on the right hand side? No, we don't. So the coefficient for t on the right hand side will be 0. In this case, we have the left hand side, 6a2 minus 4a1 is equal to 0. And again, the same here, constant. We don't have constant on the right hand side, so it will be equal to 0. And of course, you can try to use substitution, because you already have a2 here, which is equal to minus 1 over 4. You can substitute into the second equation to get a1, and then you can substitute to the third equation to get a0, right? Okay, altogether you will get a2 is equal to minus 1 over 4, a1 is minus 3 over 8, a0 is minus 13 over 32, and then you put all these coefficients back to the assumption, the assumption, this one. So a2 is what? a2 is minus 1 over 4, a1 is what? a1 is minus 3 over 8, a0 is what? Minus 13 over 32. Okay, so we get this particular solution here by substituting all the coefficients that we have found. Alright, so in general, the solution will be the homogeneous solution, this one, plus the particular solution, this one. Alright, so that's the first example, when on the right hand side, or bt, we have a polynomial. What about if we have exponential, for instance, this one, 5e to the power of t. Okay, again, we have to find the homogeneous equation, right? Find roots. It is the same with what we have before. So the homogeneous solution will be this one, Again, this is exactly the same. Okay. Now, this is on the right hand side, This is the function which is equal to bt, right? So originally, we have to assume that yp is supposed to be a constant times e to the power of t. Originally, that is the assumption. A without the t, e to the power of t. But if you check with the homogeneous solution, you will see that there is the same term there, So without the t, this one, a e to the power of t, it is the same term with this one, right? E to the power of t. So it will not work, if we use yp a times e to the power of t, because it will not be different with what we have in the homogeneous solution, The particular solution is an addition, it should be something different. Alright, so how to differ? We multiply by t, This is a very standard method, We multiply it by t. Okay, multiply by t. And again, the same, we have to find y-accent and y-double accent. What about the y-accent? Remember, this is a multiplication of t and e to the power of t. So to find the derivative, you have to use the multiplication rule. So a e to the power of t, right? The t is gone. You take derivative of t, and then the at stays the same, and you take derivative of e to the power of t, which is the same with itself, right? Okay, so you have yp accent, yp double accent now. Like this one, the derivative is just a to the power of e times e to the power of t, right? The derivative is the same with itself. What about this one? This one again, we have done it before, to find the derivative, and the derivative will be this one, using multiplication rule. Okay, this one and this one we can add up, it becomes 2a. And again, we put everything back into the original equation. Yeah, so this is double accent, put it back here, accent, put it back here, and the original y, original y is this one. Yeah, at e to the power of t, we put it back here. Let's do that. Yeah, this is the double accent. Yeah, up to here. Yeah, and this is the y accent, and this is the constant. Yeah, the minus 4 times y, sorry, not the constant, minus 4 times y. And this is supposed to be equal to the 5e to the power of t, 5 times e to the power of t on the right hand side. Okay, we can collect everything. Yeah, let's see, we can simplify first. Yeah, so we have this 2a e to the power of t, 3a e to the power of t. Yeah, so 2 plus 3 is 5. This one is at e to the power of t. This is 3 at to the power of t. So 4 at to the power of at e to the power of t minus 4. Yeah, so it will be gone. Yeah, so this will cancel each other. So altogether we only have 5a e to the power of t, which is equal to this. Yeah, left hand side should be equal to the right hand side, and of course 5a is equal to 5. And in this case we have a is equal to 1, right? Put it back to the yp, we will get the particular solution, which is just 1 times t times e to the power of t. Okay, and if we add it to the homogeneous solution, we will get the general solution. Okay, so that's about the second order differential equation with variable term. Yeah, in this case we only learn two functions, which is polynomial and exponential. Yeah, how to find the particular solution. So that's the end of second order differential equation. I hope you will learn something from this video. Thank you for your attention, and see you again in other videos maybe. Good day.